Hi, I am John Paulo Tuazon, and I will be discussing to you subnetting IP networks, specifically variable length subnet masking. Now, as an introduction, why do we need to subnet? Consider how, on an Ethernet local area network, devices use broadcast to locate needed services and devices. Remember that a broadcast is sent to all hosts on an IP network. On a large network, this could create a very significant amount of traffic which could slow down network operations. Moreover, because a broadcast is addressed to all hosts must accept and process the traffic, resulting in increased device requirements. If a device must process a significant amount of broadcast, it could even slow down that device's operations. For reasons such as this, larger networks must be segmented into smaller subnetworks, keeping them localized into smaller groups of devices and services. This process of segmenting a network by dividing it into multiple smaller network spaces is called subnetting. These subnetworks are called subnets. Network administrators can group devices and services into subnets that are determined perhaps by the geographic location, organizational unit, device type, or any other division that makes sense. Overall, subnetting can reduce the overall network traffic and improve network performance. This is the reason why subnetting plays an important role in networking. As an example, suppose that we are given an address of 192.0.0.0/8, and we need to subdivide this into two subnets. Suppose that subnet A needs 15,000 addresses and subnet B needs 7,500 host IP addresses. So to know this, on how many bits we need for the host portion of their network address, the formula for that would be 2 raised to n, n being the number of bits needed for the host portion. So that this equation would be equal to the number of hosts, including the network address and the broadcast address. So for subnet A, n would be 2 raised to 14, which would give us 16,384 host addresses, including the network address itself and the broadcast address. So this would mean that the number of bits for the host portion is 14. Then the prefix that would be added for network A would be 18. The reason for this is that on a network address, we have two portions, which is the network portion and the host portion. On the given example, we know that the number of bits needed for the host portion is 14. The total number of bits in a network address is 32. So 32 minus 14 would give us 18. And this would be the prefix for subnet A. Then, the next part of subnetting our network is for us to know the subnet mask of that subnet. To do that, we need to make all of the bits of the network portion to be equal to 1. So our guide in finding how many bits that we need to make to be equal to 1 is the prefix. The prefix tells us how many bits we need for the network address. So this would mean that 18 bits that are equal to 1 would be needed to find the subnet mask. So to do that, we just tally all the one that would be equal to 18. So, this part is the network portion of network A, and this part is the host portion of subnet A. So, to find this in decimal, we just add the number of ones in this part of that address. So, this would mean adding 1, 2, 4, 8, 16, 32, 64, and 128. And this would result to 255. The next part would be also 255. And in this part, since it would be 128 plus 64, it would just result to 192, and the rest would be equal to 0. So the subnet mask would be 255.192.0. The next thing that we need to know is the network address of our network. So, we have an original address of 192.0.0.0/8. Address 192.0.0.0/18. 18 because it's now the network address for subnet A. Then, the next thing that we need to find is the broadcast address of subnet A. So, to find the broadcast address of subnet A, we just need to make all of the host portion of the address be equal to 1. So, we have an address of 192.0.128 So, the network portion, the host portion of subnet A is this one. So, this would give us the broadcast address of subnet A. So, to do that, we just need to make all of these bits equal to 1. And that would give us 192.0.63.255. Then, the next thing that we need to know is the first host address of subnet A. So, the first host address of subnet A would just be 192.0.0.1/18. And the last thing that we need to know for subnet A would be its last host address. So, the last host address is the broadcast address minus 1 address. So, that would give us 192.0.63.254/18. So, that would give us the data that we need for knowing subnet A. So, for the next subnet, which is subnet B, we need to find the network address for 7,500 host IP addresses. So, computing again, so 2 raised to n would be the number of bits for the host portion. For example, we just use 2 raised to 5. That would just give us 32 hosts. But then, when using 2 raised to 13, that would give us 8,192 hosts. So, meaning to say, we need 13 bits for the host portion. Then, the next thing that we need to know is the prefix of subnet B. So it would just be 32 minus 13, which is equal to 19. So the prefix for subnet B is 19. Then, to the next information that we need to know is the subnet mask. So doing that again, we just need to make the network portion of the address be that all of those bits equal to 1. So these are the number of bits for the host portion, and these are the bits for the network portion. So in decimal notation, this would give us 255.224.0. So 255.255.224.0 is the subnet mask for network B. For subnet B, what we need to add just one for the broadcast address of network subnet A to know the network address of B. So the broadcast address for A is 192.0.63.255. So in binary notation, this would be 11000000, and then 63 is so for network B, we just need to add one on the host portion of the broadcast address of network A. So this would give us, still this is 192.0, but this would be 01000000.0. So this address is 192.0.64.0/19. So this is the network address for subnet B. Then, the next thing that we need to know is the broadcast address of subnet B. So, just like in subnet A, we just need to make all the bits of the host portion be equal to 1. So, still the network portion would be 192.0, and then since it's already now 64, so 0, 1, then 0. This is the network portion of the network address of network B. So the host portion would be to find the broadcast address, we need to make all these bits equal to 1. So this would give us 192.0.95.255. So this is the broadcast address for network B. Then the next thing would be the first host address for network B, and that would be 192.0.64.1/19. So we just need to add 1 to the network address to find the first host address of subnet B. So it would be 192.0.64.1/19. So the last thing that we need to know for subnet B is the last host address, and it is just one address lower than the broadcast address. So it would be 192.0.95 192.168.254/19. So this is the last host address for subnet B. And that ends my discussion on on subnetting IP networks, specifically variable length subnet masking. I hope you learned a lot in my discussion. Thank you.